All right, we're starting chapter 7. This is on lines and angles. So some of it's review, some of it's new. We're not going to be doing a lot of actual measuring or drawing angles. It's more about using the properties. So in the getting started, just ask you here to name each of these items in a triangle. Triangle's given here. Oops, see here. Okay, there's the triangle. So a point, well, point P, or any of these points that are on the vertices. But P is a point on that line, so I'll leave it as that. A line segment, so that's any of these. And it could be even from there to B to P. So we would use two letters, so AB, or you could do side AC, or BC, or BP, or PC. So there's many. An angle, so we'd use a symbol for angle, and then angle A, or we could have angle B, or we could have angle C. And a vertex, so a vertex are points A or B or C. That's where the sides of the triangle join, and we call that the vertex. So there's three. They are also points, but in particular, they're the vertices of the triangle. Next one, it says just double the measure of each angle. So you're just multiplying, double means multiply by 2. So 14 times 2 is 28. And always remember the degree symbol. 121 times 2 is 242. 73.3 is that 146.6. 164, that's going to be 329.6, I think. You can check in your calculator. I just did it off the top of my head, but yeah, that's correct. So that's doubling angles, and then a half of an angle, remember, means multiplying by a half, or it's the same as dividing by 2. So 172 divided by 2 is 86 degrees. Half of 81 will be 40.5 degrees. And these, now we're looking at 360 degrees. That's a complete rotation. So if you're standing looking forward and you turn around until you're looking forward again, you've rotated 360 degrees. When you look at a circle and the point at the center of the circle, and you rotate all the way around, you've traveled 360 degrees. So if we divide that by 2, that's half a rotation. It's 180. Divide by 60, well, the zeros divide out. 6 goes into 36 6 times, 6 degrees. And that's kind of like what a clock is. So there's 60 minutes in an hour. So if you look at a normal clock, an analog clock, there's markings for each minute on most clocks, not all of them. 360 divided by 6, that would just be 60, kind of the opposite of this, but it would be 60 degrees. And then 360 divided by 12, because there's 12 hours on the clock, so it's divided into 12 parts. 12 goes into 36 3 times, the zeros, so 30 degrees. Then the next one, determine the measure of each unknown angle. So we have to find the angle that adds with 37 to give you 90. So the fastest way is to subtract 37 from both sides. It's like an equation, right? So that's going to be 53 degrees. Same thing here. So that's going to be 84 degrees. And matching, it says match each type of angle with its description. So a right angle means it's 90 degrees. So we often use a little box between the two sides to represent that, because a box or a square has angles that are 90 degrees. Okay, so a right angle is an angle that is 90 degrees. straight angle, so we're measuring it from this point, from here, all the way to here. So that is half a rotation, half a circle. That's 180 degrees. An acute angle, here's an example, an acute angle, think of the word cute, small. So that means it's less than 90 and greater than 0, but less than 90 would be this one. Obtuse angle, here's an example, it's always bigger than 90 degrees. Okay, so obtuse is bigger than 90 and less than 180. So that would be that one. And once you go past 180, then it's a reflex angle. Okay, so greater than 180 but less than 360. Okay. Next one, it says use the circular protractor. So that goes all the way around, which is kind of nice. Determine the number of degrees in one whole circle. Well, we've already talked about that. You start at 0 here. You can see there's 0. And we're going all the way around. And so we end up 350 and another 10 is 360 degrees. Half a circle is from there to here. We already talked about that. That's 180 degrees. So that's like facing forward, rotating to face backward. I think they, like in skiing and snowboarding and stuff like that, they say we did a 180, so went forward to backwards in the air kind of thing. Quarter of a circle, well, that's a half, so a quarter would be up here. So from there to there is 90 degrees. Basically 360 divided by 4. It says draw a 25-degree angle on the circular protractor and label it. So I'm going to erase what I just did here just to make it clear. I'm going to use my ruler or my straight line in red. So it's going to start there. And 25 degrees, you look, there's 20, and it's halfway between 20 and 30. So I'm going to go there. Oh, I got an extra part to it. Sorry, just a sec. I want to get rid of this one. Okay, and then here I'm going to go right to the center. Okay, so that's 25 degrees. I'll label it. So I mark the arc. You just do a little arc, part of a circle there. On the protractor, draw the hour and minute hands of a clock to show 10 p.m. Okay, so I'll use a different color. Let's use blue. Okay, so 10 p.m. means your hour hand has to be facing the 10. So remember we talked about that. Each hour, when you divide 360 into 12, is 30 degrees between. So if we go from 12 midnight to 11, it's going to be 30 degrees. Okay, and then, so that would be 120. And then another 30 would be 150. So here, this would be the hour hand. And so normally the hour hand is shorter. So we'll go like part way there. Okay, and let me put an arrow on that. And then the minute hand is at the 12 because it's at the top, because it's right exactly on 10 o'clock. So back to my blue. And then here, so I want to go up. Oops, I'm a little bit off here. Let me just fix that a bit. There we go. It's better. Okay, so that's 10 o'clock. I guess it doesn't go all the way. Go a little bit there. Okay. Mark the arc and label the measure of the acute angle. So this angle in here, so that was 60 degrees. Okay, what are the 3 angle measures shown in the chair diagram? Well, this gives this one away. It's 90 degrees here. Okay, so that one that's measured, this one here, that's 180 minus 90, so that's 270 degrees. This is a straight line, so this is going to be 180 degrees. And then I'm assuming we need to find this one, so that's 90. Okay, and then question 11, sketch each pair of line segments. So a pair of line segments that are parallel but are not vertical or horizontal. So basically there's sort of diagonal lines. There's one, and basically right underneath. So they should be the same distance apart. So I should really measure that. If you have a ruler, you can measure it, but they look pretty close there. So often with vertical lines, we put an arrow on them, each of them, to show that they're vertical. To show that they're parallel lines. So if we don't have that, then it's not guaranteed that they're parallel. But if we have the arrows, we know that they are. Then it says perpendicular, but are not vertical or horizontal. So that means I'm not going to go like, I'm not going to go like this and this, okay? I'm going to go something like this, and then this. And then I would label it like that, with that 90-degree symbol, okay? And then the last one, we're not going to do any measuring with the protractor, so you can leave this one, okay? That's it.